Dawn crept over the English Channel like a pale veil, soft and cold, on the morning of June 7th, 1944. The stormy night had finally eased, leaving a low mist curling along the water. German coastal observers on the heights above Arromanches raised their binoculars, expecting to see the remnants of the Allied landing craft still shuttling back and forth. Instead, they froze. Out on the horizon, silent silhouettes were materializing, enormous, featureless walls rising from the sea. At first, the officers thought they were looking at damaged ships drifting in the tide. But the shapes were too straight, too uniform, too unnatural. As the light strengthened, the truth became even more bewildering. These weren't ships at all. They were colossal blocks, gray, towering, and hollow, moving slowly across the channel, pulled by small tugs that looked like insects dragging cathedrals. One officer lowered his binoculars in disbelief. Concrete. It had to be concrete. But concrete didn't float. Not at this scale. Not in this sea. Yet the evidence rolled toward them with steady inevitability, pushing aside the morning fog. Something unprecedented was approaching France, and the German naval staff suddenly faced a question their manuals had never prepared them for. How had Britain built a ship out of stone? And what else were they bringing with it? The answer began decades before, long before the beaches of Normandy burned. Concrete floating on the sea was not a miracle of 1944. Its roots stretched back to a very different war, a time when Britain faced another crisis of tonnage, another ruthless U-boat campaign, and another desperate search for shipbuilding materials. To understand why German officers in Normandy were stunned by those gray giants on the horizon, we must return to 1917, when Britain was already experimenting with the impossible. By the spring of that year, the First World War had pushed Britain to a breaking point. German submarines prowled the Atlantic with growing boldness, sinking merchant ships faster than British yards could replace them. Coal carriers, grain ships, coastal steamers, every vessel that fed Britain's war machine vanished beneath torpedo wakes. The Admiralty issued grim calculations. If losses continued at this pace, Britain's industrial heart would suffocate within months. Steel was scarce, skilled shipwrights were overwhelmed, and traditional construction simply could not keep pace with attrition. In this bleak landscape, the Ministry of Shipping began to look for alternatives that seemed, at first, absurd. Concrete had been used in piers, docks, and shore structures for decades, but the idea of shaping it into a seaworthy hull looked more like a curiosity than a solution. Yet engineers knew a simple truth. Concrete sank only when shaped to sink. When formed as a hollow hull, strengthened with mesh and steel rods, it could displace water like any ship. The concept was called ferro-concrete, a marriage of stone and steel that created a rigid shell capable of floating. It wasn't elegant. It wasn't fast. But in 1917, it offered something Britain needed even more than beauty or speed: materials that were abundant and shipyards that could be trained to pour rather than forge. So the government authorized an experimental fleet of concrete vessels. They were given a simple naming pattern: Crete followed by a number. Crete block, Crete boom, Crete cable. Hulking, boxy, and unromantic, they slid into the water as if defying common sense. At shipyards from the Clyde to the Tyne, workers built wooden molds the size of houses, laid cages of reinforcing steel inside them, and poured concrete day and night under blackout conditions. When each hull cured, a slow, nerve-wracking process watched by engineers who feared cracks or warping, the ships were eased into rivers and estuaries with cautious optimism. To the surprise of many veterans, they floated perfectly. Some were tugs, some were lighters for coal and cargo. Others ferried supplies between larger ships and harbors. They were slow, heavy, and stubborn in the water, but they were also tough. Shell fragments bounced harmlessly off their thick hulls. They didn't burn. They didn't rust. And they could be built with far less steel than traditional ships, releasing precious metal for frontline vessels. By the end of the war, dozens of concrete ships were in British service, and many would remain active long into the interwar years. Some were laid up in estuaries, their cracked hulls becoming wildlife havens. Others were beached intentionally to serve as breakwaters and pier foundations. Along lonely stretches of British coastline, their shapes still emerge at low tide, silent monuments to a wartime gamble that unexpectedly succeeded. Yet these early ferro-concrete vessels were only the first chapter. After 1918, Britain shelved the idea of large-scale concrete shipbuilding. Steel returned to the yards. Peace returned to the seas. The Crete fleet, once a crucial experiment, faded into obscurity, remembered only by engineers, coastal villagers, and a few naval planners. But the idea lingered quietly in folders and archives. If steel ever ran short again, concrete could return, not as an emergency experiment, but as an industrial solution. That moment arrived far sooner than anyone hoped. 2 decades after the first Crete ships launched, Europe plunged once more into war. German submarines again hunted British supply lines with merciless precision. Merchant losses once again climbed beyond the capacity of British shipyards. And in 1940, as the Battle of the Atlantic grew into a struggle for national survival, the Ministry of War Transport confronted a truth older than any strategy. Steel was finite. The sea was endless. And concrete, ordinary, unglamorous concrete, might once again be Britain's unlikely lifeline. It was from this quiet revival of ferro-concrete shipbuilding that the story of the concrete ships at Normandy truly began, even though no one yet imagined the scale of what would come. The Second World War exposed Britain's industrial vulnerabilities with brutal clarity. In the first 18 months alone, German U-boats tore through merchant shipping with an efficiency that shocked even the Kriegsmarine's own planners. Tankers vanished into the Atlantic depths. Ammunition ships erupted in fireballs. Grain carriers, troop transports, even coastal barges, no route was truly safe. Britain required millions of tons of supplies each year simply to exist, yet the lifeline that kept the island alive was being carved apart one convoy at a time. In this atmosphere, steel became more than a resource. It became a battlefield in its own right. Every major British shipyard was consumed with urgent naval construction. Destroyers, escort corvettes, minesweepers, each required thousands of tons of steel and the full attention of skilled metalworkers. Merchant ships, though vital, had to compete for material with the Royal Navy's desperate need for escorts. Cargo vessels were therefore built slower, patched repeatedly, and sent back out long before proper repairs were completed. The demand never eased. Every week, the Admiralty studied convoy reports and knew the truth. Even if Germany never invaded, Britain could still be strangled into collapse by the loss of shipping. And so, just as in 1917, eyes turned once more toward the ungainly but practical idea of ferro-concrete. Engineers who had studied the old Crete fleet dusted off their notebooks. Wartime planners examined what could be built quickly, cheaply, and with minimal strain on steel reserves. The conclusion was straightforward. Anything that did not require speed, anything meant for harbor service, coastal transport, fuel storage, or nearshore logistics, could be made from concrete. By shifting low-priority hulls to this material, steel could remain reserved for warships and fast merchantmen. What followed was a quiet but substantial industrial campaign. New molds were built in coastal yards and inland factories. Reinforcement cages were assembled by workers who had never built ships before. Concrete mixers churned through the night under air raid sirens. Out of this frenetic activity emerged an entire family of ferro-concrete vessels. Barges, lighters, fuel carriers, water carriers, repair pontoons, and even floating workshops. They were simple structures, long, blocky, and utilitarian, yet they filled a crucial gap in Britain's wartime logistics. By 1942, hundreds of these concrete barges were in operation. Some shuttled coal along the west coast, freeing steel-tonnage ships for more demanding routes. Others transported grain, machinery, or ammunition between Britain's industrial ports. Many were anchored near naval bases, acting as floating storage tanks or maintenance platforms. The crews who worked with them often joked that the barges felt more like floating buildings than ships. They were slow to start, slow to stop, and unforgiving to maneuver, but they did their job with quiet reliability. Still, no one imagined at this stage that concrete would play a role in the largest amphibious operation in history. These barges were a solution for shortages, not a weapon for invasion. Yet in the same offices where ferro-concrete projects were approved, Allied planners were confronting a question far more daunting than shipyard capacity: how to one day return to mainland Europe. By late 1942, the possibility of a cross-channel invasion was slowly taking shape. The Americans wanted an early assault. The British urged caution, mindful of the disasters at Dunkirk and Dieppe. But all agreed on one impossible truth: if the Allies ever landed in France, they would need a port, not within weeks, but immediately. The German army had fortified every major harbor from Brittany to Belgium. Capturing one intact was improbable. Using a damaged one would be slow. Landing across beaches alone would never sustain the divisions needed to break out of Normandy. The problem was as vast as the sea itself. How do you feed an army across open surf? The answer did not appear suddenly. It emerged piece by piece, from discussions about floating piers, from engineering experiments on breakwaters, from analyses of tides and weather. As these concepts gathered momentum, ferro-concrete shifted from a background convenience to a central pillar of an audacious logistical design. Britain's engineers were not simply going to build barges or coastal lighters. They were going to build something on a scale no one had attempted: a harbor that could be transported, assembled, and anchored off an enemy coast. And for that immense task, the lessons learned from 2 wars of concrete shipbuilding would become indispensable. With the invasion planning accelerating and the stakes rising with every lost merchant ship, concrete was no longer just an alternative material. It was becoming a strategic weapon. The idea of a concrete ship still feels counterintuitive even today. It violates instinct. Stone should sink, steel should float, yet the physics of the sea cares little for instinct. What mattered was displacement, shape, and strength. And as Britain's wartime engineers confronted the monumental challenge of creating floating structures that could anchor a harbor in the open surf of Normandy, they relied on principles that had been tested quietly for decades. Their work revealed the first angle of this story: the engineering foundation that made the impossible appear ordinary. Ferro-concrete was not magic. It was geometry and patience. Concrete alone was brittle, but when wrapped around a skeleton of steel bars, a lattice running along every curve and corner, it became something different. Its immense compressive strength allowed whole walls to withstand wave pressure, while the steel reinforcement absorbed tension and flex. The result was a rigid shell strong enough to survive grounding, storm impact, and even the shock of nearby explosions. Engineers shaped these shells into vast hollow blocks, each with internal compartments to trap air and generate buoyancy. The thickness of their walls acted like armor against the sea. It was not elegance that made them float, but mass carefully controlled and organized into form. The men who designed them knew the limits. They would never rival steel ships in speed or finesse. But they did not need to. They needed only to endure. In these quiet workshops and drawing offices, the first seeds of mulberry harbors were planted long before anyone knew their name. Yet a blueprint alone could not build a harbor. Across Britain, the task fell to thousands of workers who had never set foot on a naval ship. In towns from the Tyne to the Clyde, from Southampton to the Welsh coast, entire communities were drawn into a project cloaked in secrecy. They built wooden molds the size of warehouses, hammered steel reinforcement into cages taller than houses, and poured thousands of tons of concrete under blackout curtains and the thrum of air raid sirens. Many were shipyard veterans. Others were miners, carpenters, or factory hands redirected into wartime industry. They learned quickly, not through textbooks, but through aching backs, chilled hands, and the rhythm of wartime urgency. In the early months of 1943, these men and women labored on components whose purpose they were not allowed to know. The scale alone suggested something extraordinary. The structures towered over the yards, their walls thicker than any ship hull Britain had ever produced. Workers poured concrete into forms that stretched across entire docks, curing them slowly to avoid cracking. Welding crews connected internal frames, carpenters reinforced scaffolding, and inspectors tested every seam for weakness. Many of these laborers never saw a single day in uniform, yet their fingerprints remain embedded, quite literally, in the concrete that shaped the invasion. When the time came to move these giants from their molds, the workforce gathered to watch, anxious and proud. Each successful launch into the river or estuary felt like a small victory against the forces that threatened their country. All the while, on the other side of the channel, German naval staff studied Allied ship movements and coastal preparations with meticulous care. Their focus stayed on aircraft carriers, destroyers, landing craft, and troop transports, the traditional tools of invasion. They were aware of Allied experimentation, but concrete hulls did not concern them. Barges, storage pontoons, and auxiliary lighters were considered minor elements in the machinery of war. The Kriegsmarine's analysts expected the Allies to rely on seizing ports, not building them. Their doctrine was built around denying those ports, fortifying Cherbourg, strengthening Le Havre, reinforcing Calais, and mining every channel leading toward them. The Germans prepared to repel landings at beaches, but they assumed any large-scale invasion force would be crippled without a port to unload tanks, fuel, and ammunition. This blind spot would become one of the most consequential miscalculations of the war. German intelligence monitored British shipyards, but even aerial reconnaissance struggled to interpret what they saw. The concrete structures rising from British coastlines looked like breakwaters, caissons, or foundations, static, immovable, belonging to the shore. Few could imagine that these vast gray blocks were designed to float, much less to cross the channel. And even if some officer recognized the possibility, the concept seemed strategically absurd. No navy in history had attempted to tow artificial harbors to an enemy coastline and anchor them under fire. The German command dismissed the notion as impractical, if they considered it at all. But while German analysts focused on warships and troop movements, the British had begun to assemble a weapon that would not fire shells or launch torpedoes, a weapon of logistics, built from ordinary stone and steel rods, destined to reshape the course of the war without a single shot. The convergence of engineering ambition, industrial determination, and enemy oversight was now set in motion. The next phase of this story would reveal just how radically these concrete structures would transform the invasion plan, and what they would mean once the landings began. As the Allies refined their plans for the return to Europe, the true scale of what they needed became painfully clear. It was not enough to land men. It was not enough to land tanks. The invasion army required an uninterrupted river of supplies, food, fuel, ammunition, vehicles, medicine, spare parts, hundreds of thousands of tons each month. A single day of stalled delivery could cripple the advance. Beaches alone could never support that burden. And so the Allies devised one of the most audacious logistical creations in military history, the Mulberry Harbors. They were not ports built by engineers. They were ports assembled by sailors in the surf. And at the heart of their design were the massive concrete caissons that would become the breakwaters protecting this artificial port from the fury of the channel. Each Mulberry Harbor was a symphony of components. At the outer edge sat the block ships, a line of scuttled vessels forming the first barrier against waves. Behind them, the concrete giants took their place, the Phoenix caissons. These were the largest floating concrete structures ever constructed, some weighing over 6,000 tons. Their hollow interiors allowed them to float just high enough to be towed. Once in position, valves were opened, seawater filled their compartments, and they settled onto the seabed like monoliths planted by an ancient civilization. Between these lines of concrete and steel rose pontoon roadways that flexed with the tides, leading to pierheads that rose and fell on hydraulic legs. Ships could unload in open water, transfer their cargo to these floating piers, and push the supplies directly toward the shore. It was a harbor without land, a port without foundations, a masterpiece of military necessity. Concrete, once a symbol of immobility, became the backbone of a moving city. While Allied planners spoke in diagrams and tonnage, the German defenders viewed the invasion differently. Their eyes scanned the beaches, the cliffs, the roads leading inland. They believed the battle would be decided in a race between Allied firepower and German counterattacks. Like most of their high command, they assumed the invaders needed a major port to survive. Without Cherbourg, without Le Havre, without any deep-water facility intact, the enemy army would crumble under the weight of its own logistics. Even after the landings began, this belief shaped German decisions. Reports flowed from coastal batteries observing endless streams of landing craft, tanks, and men. But no port was visible. No wharves, no piers, no cranes. German officers watched the chaos of D-Day and concluded that the Allies had achieved only a fragile foothold, one that would falter within days if the expected counterattack succeeded. That illusion began to fracture on June 7th and 8th, when the first concrete walls appeared offshore. Through binocular lenses clouded by spray, German observers saw shapes they could not categorize. At first, they assumed they were barges, then damaged ships, then perhaps parts of a pier. But as the silhouettes multiplied, confusion hardened into concern. These structures were too uniform, too massive, and too deliberately positioned to be debris. Something new was unfolding, something outside the boundaries of German expectations. Messages crossed the command network, asking for identification. No one had an answer. What they were witnessing was a weapon they had never prepared for, a harbor assembling itself under their guns. This revelation carried weight far beyond engineering. It marked a psychological blow to German defenders who had been assured that the invaders would soon collapse. For the Allied troops on the beaches, however, the sight of these floating fortresses brought a surge of reassurance. Supplies would come. Reinforcements would arrive. The invasion was not a gamble. It was a sustained effort backed by a logistical engine unprecedented in warfare. The concrete caissons represented stability in the middle of a battle where everything else was uncertain. Their arrival felt like a promise that the soldiers fighting inland would not be abandoned to chance or tide. But beneath the strategic and emotional layers lay a deeper truth. The mulberry harbors symbolized the difference between two wartime mindsets. The German command, confident in fortifications and fixed positions, relied on denying the enemy what existed. The Allies, unwilling to rely on chance, chose to create what did not exist. They replaced shortage with invention, vulnerability with construction, and impossibility with engineering. The concrete ships of Normandy were not improvised wonders nor symbols of desperation. They were the embodiment of a strategic philosophy that turned the ordinary into the decisive. And as these immense structures locked themselves into place off the Norman coast, their role shifted from idea to reality. They were no longer theories on paper, no longer shapes rising in distant shipyards. They had arrived at the front line, ready to face the full violence of war and the unforgiving sea. Now the stage was set for the turning point, the moment when these concrete giants would meet their greatest test, and the fate of the invasion would hang on whether they could endure the storm that was coming. In the final days of May 1944, the quiet estuaries and shipyards of southern Britain came alive with movement. Dawn after dawn, tugboats pushed off from their moorings, cables strained, and massive gray forms began sliding out into deeper water. At first glance, they resembled stranded fortresses, rectangular, towering, silent. But these were no static structures. They were the Phoenix caissons, the concrete heart of the mulberry harbors, and the time had come for them to begin their journey toward France. Each caisson was a leviathan. Some stretched nearly 200 feet, rising from the water like the side of a battleship stripped of guns and paint. Their reinforced walls were thicker than a man's height, and their hollow compartments echoed with the groan of shifting tides. Workers who had poured them, cured them, and watched them take shape now stood along the riverbanks as the giants departed. Many did not yet know what these structures would become, only that they had been built for a moment that carried more weight than any single invasion. The convoys that towed them moved carefully, almost cautiously, as if escorting an endangered species. Navigation was slow. Each caisson resisted the pull of the tugboats, its enormous mass reacting sluggishly to changing current. But mile by mile, they slipped downriver until the open sea swallowed them. There, in the cold wind of the channel, they joined dozens of others, forming long lines behind the invasion fleet. Destroyers and transports raced ahead, carrying troops destined for the beaches. Behind them came the second wave, the floating foundations of the harbors that would keep those troops alive. In the early hours before D-Day, the Phoenix fleet waited offshore, anchored in the darkness as Allied warships hammered the coast of Normandy. Naval guns lit the night in orange bursts, and the air trembled with the droning thunder of aircraft passing overhead. The concrete structures drifted in the swell like silent witnesses, their flat surfaces reflecting the flashes of bombardment. They were not built for violence. They were built for endurance, and their moment had not yet arrived. Once the beaches were secured on June 6th, the call went out. The Phoenix caissons were to be brought forward, positioned, and sunk into precise locations to form the backbone of the new harbors. The operation required timing, coordination, and nerve. Engineers aboard small control vessels spoke in terse instructions as they guided each caisson into place. The crews had only one chance to get it right. Once a caisson began flooding its compartments, there was no reversing the process. The first to arrive off Arromanches approached at dawn. Through the smoke drifting over Gold Beach, the tugboats nudged the concrete giant into alignment. Engineers opened the intake valves. Seawater rushed into the caisson's hollow chambers, and within minutes it began sinking slowly, deliberately, until its floor touched the seabed. It settled with a deep, resonant shudder, locking itself into the earth beneath the waves. One after another, more Phoenix units drifted forward and repeated the same ritual, forming a defensive wall against the channel's relentless surf. It was a sight unlike anything the sea had ever known. Blocks the size of apartment buildings descended into the water, creating an artificial breakwater where only hours earlier there had been nothing but open sea and enemy fire. The line grew longer, stretching like a gray spine parallel to the beach. Behind it, smaller craft maneuvered floating roadways into position, linking them to pierheads that bobbed rhythmically with the tide. What had begun as an idea scribbled on blueprints had materialized into a functioning harbor, built not over months of construction on land, but in days, under fire, in the unpredictable waters of the channel. German artillery attempted to disrupt the operation. Shells whistled overhead, landing in fountains of spray. The Allies responded with smoke screens, counter-barges, and ceaseless aircraft patrols. But there was little the defenders could do. The Phoenix caissons were simply too large, too resilient, and too essential to be turned back. Even near misses caused little damage. Fragments bounced off their concrete walls or chipped harmlessly. The tides rose and fell. The waves crashed. Still, the walls held. As the first elements of Mulberry Bee took shape, Allied officers monitored the progress with growing confidence. Every caisson that settled into place meant greater protection for the supply ships waiting offshore. Every pierhead connected meant another lifeline from ship to beach. The logistical machine of the invasion had begun to turn, fed not by captured ports, but by these floating monoliths. Yet no triumph on the channel lasted unquestioned. The Allied planners knew the greatest enemy was not German artillery or Luftwaffe bombs. It was the sea itself. The channel, notorious for its sudden fury, had granted them calm water during the landing. But currents were shifting, winds were rising, and a storm was gathering far beyond the horizon. The caissons had proven they could be towed. They had proven they could be positioned. They had proven they could form a harbor under combat conditions. But the ultimate test still lay ahead. A test that would decide whether the concrete fleet would endure or be torn apart by the very waters they were meant to tame. For the first few days after the landings, the channel behaved with an almost eerie restraint. Winds stayed light, Waves remained manageable, and the newly assembled Mulberry harbors at Arromanches and Omaha began to breathe life into the invasion. Ships queued in steady lines offshore. Barges shuttled cargo along the floating roadways. Trucks rumbled down the pier heads, their tires gripping metal plates still slick with seawater. For a moment, it seemed as if the greatest logistical gamble of the war had worked flawlessly. But the Channel is not a patient ally. It gives no guarantees and keeps no promises. In the third week of June, far out in the Atlantic, a storm began to gather. It was not a typical summer squall. It was a deep, spiraling low-pressure system, one of the strongest June storms the region had seen in decades. Weather forecasts were uncertain, disrupted by wartime secrecy and limited observation. The Allies knew bad weather was coming, but few realized what was about to strike. On June 19th, the wind rose before dawn, first a moan, then a roar. The sea followed quickly. Waves that had lapped gently at the shore only a day earlier now reared upward, slamming into the concrete walls with explosive force. By mid-morning, Mulberry A, the American harbor off Omaha Beach, was already fighting for its life. The floating piers bucked like trapped animals. Pontoon joints twisted until bolts sheared off. Barges snapped their ropes and spun helplessly. The storm intensified hour by hour, turning the artificial harbor into a battlefield far more violent than anything German artillery had inflicted. At Mulberry B, off Arromanches, the scene was just as brutal. The Phoenix caissons, anchored deep into the seabed, resisted the assault with stoic resilience, but every impact reverberated through their thick walls. Water surged over their tops. The block ships offshore groaned under the constant hammering, some breaking apart as the relentless waves tore at their weakened hulls. Allied sailors, drenched and exhausted, struggled to secure vessels drifting dangerously close to the breakwaters. Engineers ran between anchor points, shouting orders drowned by the wind. The storm was not a single wave or a single moment. It was a continuous onslaught that lasted for days. Mulberry A was the first to fail. Its position in a more exposed stretch of coastline left it vulnerable, and as the storm reached its peak, the harbor's structural integrity gave way. Pontoon causeways folded in on themselves. Pierheads tore free. Several Phoenix caissons shifted, their foundations scoured by the violent swell. By June 22nd, the American harbor was a ruin, scattered debris, sunken sections, broken roadways twisting in the foam. It had served only long enough to support the first critical days of the invasion, and now it was gone. For a moment, despair flickered through Allied command. The loss of Mulberry threatened to choke the rapid buildup of American forces. German planners, observing the destruction from afar, briefly believed the storm had delivered what their coastal defenses could not, a decisive blow to the Allied foothold. But then the truth became clear. Mulberry B, the British harbor at Arromanches, was still standing. Damaged, battered, and tested to its limits, yes, but standing. The Phoenix caissons had done what steel hulls never could. Their enormous mass anchored them through the most violent moments of the storm. Where floating piers collapsed, the concrete walls refused to yield. Where smaller ships capsized, the caissons absorbed impact after impact and remained upright. Engineers worked through the chaos, reinforcing joints, repositioning roadways, and salvaging whatever could be repaired. When the storm finally began to weaken on June 22nd, the harbor emerged like a survivor staggering out of the surf, bruised but alive. As the skies cleared, Allied command faced a crucial decision. Should the battered remnants of Mulberry be abandoned or restored? The answer was immediate. Repair crews mobilized. Welders and crane operators worked around the clock. Within days, the harbor was functioning again, not at full capacity, but well enough to continue feeding the armies pushing inland. For the Germans, the realization came slowly and then all at once. Their hopes that the storm had undone the invasion evaporated. Reconnaissance confirmed what they had feared but never fully understood. The Allies had not come to conduct a raid or gamble on a lucky breakthrough. They had come with a floating port capable of surviving a tempest and sustaining an army. The Channel storm had not broken the concrete fleet. It had proven it. And as the guns of Normandy thundered inland, the outcome of the campaign and the fate of Western Europe began to shift decisively in the Allies' favor. When the winds finally died and the Channel calmed, the full scale of the storm's damage revealed itself in the gray morning light. Wreckage drifted along the beaches. Broken pontoons lay half-buried in the sand. Tugs were stranded at awkward angles where the waves had thrown them. Yet behind the debris, behind the exhaustion etched into every face along the shoreline, stood the unmistakable silhouette of Mulberry Bee, wounded but functional, its concrete walls still gripping the seabed like anchors sunk into history. The days that followed became a race against time. Supplies had to continue flowing ashore, for the battle inland was escalating. The Allied advance depended on fuel for tanks fighting toward Cannes, ammunition for artillery battling through Bocage country, and food for tens of thousands of soldiers now entrenched in the hedgerows. Without a steady lifeline, the momentum of the invasion would slow to a crawl. And so Mulberry Bee, still braced behind the Phoenix caissons, became the beating heart of the entire Western Front. Repair crews converged on Arromanches with relentless determination. Welders patched broken roadway joints. Engineers reinforced the anchoring points of the surviving piers. Divers braved the swirling undertow to inspect the base of each caisson. The work was constant, dangerous, and exhausting, but it never stopped. Within a week, the floating roadways were once again carrying trucks, jeeps, ambulances, and fuel tankers. The harbor roared back to life, not with the pristine efficiency of its first day, but with a gritty resilience born from surviving the storm. The numbers that followed were staggering. Through Mulberry Bee, the Allies unloaded more than 500,000 tons of supplies in the weeks after D-Day. Ammunition, fuel, medical equipment, artillery tractors, engineering vehicles, radios, rations, everything required to keep an army advancing into France passed across those concrete foundations. On some days, the harbor handled cargo equivalent to a fully operational deep-water port. It functioned not because the sea allowed it, but because the concrete backbone held the sea at bay. American forces, deprived of Mulberry A, adapted with characteristic speed. They shifted operations to open beaches, developing a rhythm of direct landings that exploited favorable tides and rigorous coordination. Their success was impressive, but it could never match the consistent throughput of a protected port. Thus, Mulberry Bee became not only a British achievement, but an Allied one, a shared logistical platform that strengthened every army fighting across the Normandy front. German commanders studying the situation began to understand the scale of the disaster they faced. Hitler's Atlantic Wall had been designed around a simple assumption: deny the invaders ports, and you deny them victory. Yet off Arromanches lay the quiet refutation of that philosophy. The enemy had built a port of their own, one that storms could barely destroy and German guns could not reach. Through reconnaissance reports and interrogation of prisoners, the German staff pieced together the truth. The Allies had solved a problem the German High Command had believed unsolvable. Their armies would not starve on the beaches. Their supplies would not falter. Their advance would not stall. By late July, as Operation Cobra prepared to burst through the German lines in the west, the role of Mulberry Bee had already become legendary among those who depended on it. Convoy after convoy arrived offshore, trusting the harbor's concrete breakwaters to shield them from the rough northern waters. The beachhead, once vulnerable and thin, had grown into a sprawling logistical metropolis, cranes lifting cargo at all hours, trucks rolling down the causeways, signals teams directing the ceaseless flow of material. The harbor had become a symbol of permanence, a message broadcast across the waves. The Allies were not leaving. The success of Mulberry Bee carried more than tactical weight. It reshaped the psychology of the campaign. Allied commanders no longer worried about sustaining operations. They planned for expansion. German soldiers no longer believed the invasion could be reversed. They braced for encirclement and retreat. In a war driven by armor and aircraft, it was concrete, poured in secrecy, towed across a hostile sea, and anchored in bloodied surf that secured the foundation upon which victory began to rise. And as the front lines pushed deeper into France, the harbor remained, unglamorous yet indispensable, fulfilling the promise it had made on the morning it arrived, that the invasion would not fail for lack of supply. When the Allies finally broke out of Normandy and swept across France, the constant roar of Mulberry began to fade beneath the thunder of advancing armies. The harbor that had sustained the foothold was no longer the center of the war's attention, yet its concrete skeleton continued to serve with quiet endurance. Long after Allied troops liberated Paris and crossed the Seine, the caissons at Arromanches remained rooted in the surf, receiving ships, unloading supplies, and feeding the momentum that pushed the front line toward Germany. Even as new deep-water ports were captured and repaired, Mulberry remained in daily use, a testament to the foresight of the engineers who conceived it and to the strength of the concrete walls that had resisted both storm and enemy fire. By the autumn of 1944, its workload gradually diminished. Antwerp reopened. Cherbourg, after extensive repairs, returned to service. Major supply lines shifted, and the artificial harbor transitioned from a critical artery to a supporting structure. But it was never abandoned abruptly. For months, a steady trickle of cargo still passed across its floating roadways. Military planners knew that redundancy was safety, and the men who ran Mulberry kept it operating as long as it could provide benefit to the war effort. The last significant cargo movements continued into late winter, after which the harbor systems were slowly powered down. The structure that had once been a lifeline transformed into a relic even before the war ended. With victory in Europe declared in May 1945, attention shifted from necessity to assessment. The surviving Phoenix caissons stood in the shallow water like monuments, massive, immovable, streaked with algae and scarred by months of waves. Military engineers surveyed their condition and faced a simple question: what should be done with these concrete giants now that their purpose was complete? Some were left in place, becoming permanent fixtures of the Arromanches coastline. Others were towed back to Britain, and a few were repurposed for entirely new civilian roles. Concrete, after all, does not vanish. It endures, sometimes for centuries. Along the coasts of Britain and France, several caissons were deliberately grounded to serve as breakwaters, protecting fishing harbors and small ports from winter storms. Their massive bulk made them ideal for this peaceful duty. In some towns, they became unexpected landmarks, sun-bleached, grass-topped islands visible at low tide, visited by curious locals and children exploring their hollow interiors. Others found their way into industrial use, static storage platforms, foundations for small piers, or even training grounds for naval divers. Decades after the guns fell silent, these silent hulks continued to shape the shores they guarded. The smaller concrete barges and lighters built during the war also enjoyed long, unassuming afterlives. Many returned to commercial service on rivers and estuaries, carrying cargo for companies that valued their durability. Some became floating workshops. Others were sold for scrap value, but proved too stubborn to dismantle. You can still find their remains embedded in the mud of quiet inlets, cracked, moss-covered, yet unmistakably the descendants of Britain's wartime improvisation. In a few places, historians and local communities recognized the heritage embodied in these vessels. Efforts were made to document them, preserve them, or at least ensure their stories were not lost to the tides. A handful have been cataloged as historical artifacts, their photographs archived in museums and maritime collections. Visitors walking the beaches at Arromanches can still see the outlines of the caissons at low tide, rising from the sea like the ribs of a vast shipwrecked creature. They no longer guard supply convoys, but they guard memory, the memory of a time when the world's fate hinged on stone shaped into ships. Their endurance holds a quiet poetry. Built in secrecy, launched in urgency, tested in storm and battle, they now rest in silence. Their mission is over, but their presence lingers in the tidal rhythm of the coast. The war moved on, the armies marched east, and Europe rebuilt itself, but the concrete walls remain, a reminder of the moment when ingenuity, necessity, and courage converged on the shores of Normandy. And in their stillness lies the perfect transition to the final chapter, understanding what all of this meant, not only for the war, but for the very nature of human invention. Today, the tide rolls in and out around the remnants of the Mulberry Harbor at Arromanches with a rhythm far more ancient than war. The waves glide along the shattered edges of concrete, slipping through the rusted frames and hollow chambers that once held back the fury of the channel. To the casual visitor, these hulks might seem like relics of some forgotten industrial project. But to those who know their story, they stand as quiet proof that history is not always shaped by the loudest weapons. Sometimes it is shaped by the simplest materials, sand, water, gravel, bound together and poured into forms that defy expectation. The concrete ships and caissons of the Second World War remind us that victory is rarely won by brilliance alone. It is often won by persistence, by the refusal to accept that a problem has no solution. Britain and her allies faced a challenge that seemed insurmountable: how to land an army on a fortified continent without a port. Their answer was not elegant, and it was not glamorous. It was practical, heavy, and crude. But it worked, and in its success lies a deeper truth about human ingenuity: that innovation often emerges not from ideal conditions, but from desperation met with relentless creativity. For the German officers who watched those concrete walls drifting toward Normandy, the sight was more than puzzling, it was unsettling. It marked the moment when their understanding of the war no longer aligned with reality. The invaders were not improvising. They were building. They were planning for permanence. They had brought with them not just soldiers and tanks, but the infrastructure of an entire campaign. The concrete blocks rising from the sea were a message delivered in stone. The Allies had come to stay. Decades later, those same blocks sit half-submerged, softened by moss and salt. They do not boast or proclaim. They endure, and in their endurance, they tell a quiet but timeless story. That history bends not only toward the boldness of commanders, but toward the choices of engineers. That wars are decided not only by courage in the field, but by foresight at the drafting table. And that sometimes the most improbable creations, even a ship made of concrete, can change the course of a continent.